Good afternoon, everyone. So today we're doing something a little different. I'm doing an example given to me by one of my former students from an in-person school. It's related to trig identities. So let's, or like the trig unit. So let's get started. The question here is determine the solutions for each equation on the interval from 0 to 2 pi. Give exact solutions where possible, round approximate solutions to the nearest tenth of a radian. And we're going to do example this one, where we have 2 sine x secant x minus 2 root 3 sine x, equals 0. For this, the first thing to do is kind of write everything in terms of sine and cos. So I'm just going to do 2 sine x over cos x, because secant x is just, 1 over cos x. This is just minus 2 root 3 sine x is equal to 0. All right, now we're going to factor out a common factor between these two, and 2 sine x is a common factor. So I'm going to factor out 2 sine x, and we're going to get, actually, hold on, give me 1 second. Yeah, so let's factor out 2 sine x. It's going to be 1 over cos x minus root 3 is equal to 0. So now we have 2 factors that are equal to 0. At this point, we can solve by just taking a look at each factor individually. So we'll have 2 mini equations. 2 sine x is equal to 0. That's one equation. And 1 over cos x minus root 3 is equal to 0. So we can individually solve these, and we can solve the equation. The question, sorry. So 2 just goes over, divide both sides by 2. It just cancels out. So x is equal to the inverse sine of 0, which, if you remember, when is sine x equal to 0? When's it a node, or when's it in at the center? And if you're doing this in degrees, you'll get 0 degrees, you'll get 180 degrees, and you'll get 360 degrees. Now this question is asking for radians. So just change your calculator to radians, and let's do that. We can just do shift sign of 0, and you'll get the right answer. But first you got to change it into radians. Oh, let me do that now. So shift sign of 0, it's still 0 because that's still 0 radians. How do I convert 180 to radians? Well, that's just multiplying by pi over 180. So you'll get 1 pi radians, or just pi radians, same thing. And 360 is obviously 2 pi radians. So that's the answer for the first factor there. Remember, this is all grade 11 stuff. Nothing so far has been, that much grade 12. As for this question, same thing. 1 over cos x is equal to root 3. Bring the negative root 3 over, it becomes positive. And then I'm just gonna kind of crisscross applesauce, multiply it, and you should get cos x is equal to 1 over root 3. And then I guess if you want, you can do over 1, doesn't really matter. So once we have this, we know that x is going to equal the inverse of 1 over root 3. And what does that equal to? If you use your calculator, and you have it in radians, because we are doing it in radians, you do 1 divided by root 3, and you get 0.5777, and then you use shift cos answer, and you should get an answer of 0.95 radians. Well, it's 5, so I guess we can round up to 96 radians. All right, so 0.96 radians is the answer for this second factor. The only thing is, hopefully you can recall that whenever we're doing a question when it comes to a periodic function, like one of our trig functions, usually there are 2 possible solutions for a range of 0 to 360 degrees. So this is cosine, and cosine, the ratio is positive. So if you remember correctly, the cast rule lets us know where the ratio should be positive. So for cosine, the ratio would be positive in quadrant 1 and in quadrant 4. And you make your triangles. And the value here is this 0.96 radians. We know that this is 2 pi. Pi over 2, pi, 3 pi over 2. Or like 0, 90, 180, 270, 360. So for us to get the principal angle from here to here, we just have to subtract the angle that's inside this triangle, which is 0.96 radians. So the answer is going to be 2 pi minus 0.96, which you just get a calculator. You do 2 times pi minus 0.96, and you'll get an answer of 5.32 radians. And that is the answer. So there's almost always a minimum of 2 possible solutions when it comes to these trig functions. All right. Good luck.